Welcome. This is our last video of the semester for CSCI 1061, talking about some more design patterns than the ones we explored earlier in the course. This is the last video just because this is the last topic that I think is the most important to go through. There's a few other things that we'll cover in the course after this, but this is the last thing that I'll be recording. So in our first exercise, we're going to use the singleton design pattern, where we make a control unit class that's going to have a static pointer to a control unit and a getInstance method that is going to make sure that we only ever have a single control unit. So what this means is we're going to go over here and do more design patterns. Let's go make our file. This is example 1. Okay, so let's make our control unit class. It's called control unit. And it is going to have a static pointer to a control unit called instance. And so what we're trying to do here is make sure there is only ever one control unit. You cannot have a second one. To ensure this, let's actually also make sure that we have something that we can use to verify the identity of our control unit, but we just call it ID. For our control unit constructor, actually, do we need a control unit constructor? We may not. Actually, I think we do. Just trying to think. Will I need one? Let's put one in and we'll see what happens. So ID equals 0. Actually, let's say I equals 0 here. I think I can do that. Now, the function that I need to write is a function control unit star get instance. And it's going to have two possibilities. If our instance doesn't exist yet, it's a null pointer, then we will say instance equals new control unit. I think that's what I want to do, and return instance. Otherwise, we just return the instance. Now, I think I need to put the constructor here. It's been a while since I've done this, so I'm going to make sure I'm doing this right. But let's experiment a little bit, and we can figure out what will actually happen here. So the first thing is I don't want to be able to create a control unit just out of nowhere. So this presumably should not work. Let's see if it does. Oops. Example 1. Okay, so yeah. The control unit constructor is private, which means that I can't just go and build a control unit. You're not allowed to do that, which is actually what I want. I don't want to be able to just make control units willy-nilly. But what I do want to be able to do is to have, so this is a static method. I should emphasize that probably here, right? And a static getInstance method. So to call this, I need to say from the control unit class, getInstance. And I think this should compile. I think this should be acceptable. Am I right? Conversion from, oh, right. I'm looking for a pointer. I can't actually make a thing. I can only make a pointer to a thing. Is that okay? Oops, not happy. Undefined reference to control unit instance. I think this warning is just because it wants to make sure control unit instance equals null pointer. I think I need to have this to prevent that warning. Does that work? Yeah, okay. So basically I want to be extra sure this is null pointer. I wonder if I can put it here. Will that get rid of the error? Let me see. Can I do that? No, I'm not allowed to do that. Okay. So basically I need to make sure that initially my instance doesn't exist, just a null pointer. And then I can now get that control unit. Let's get some functions to play with the ID so we can make sure that we know what's the difference between our different control units. So we'll say, first of all, int get ID, return the ID, int set ID, int ID equals I. So here's what I want to do. Let's make a control unit C and another control unit C2. C dot set ID to 5. Do I have, I don't have my libraries in here. Include IOStream, use the standard namespace. Let's output C dot get ID. CID equals this. And then do it for C2. And then we'll set C2's ID to 50 and then see if anything changes. I'll put this code in here to get printed out, so we can really see what's happening here. Okay, so we'll set the ID for C to be, oh, and it shouldn't be dot, it should be a arrow, because these are pointers. So let's set some IDs to some values and see what happens. Okay, compile, we're okay here. Oh, nope, it's very unhappy. No return statement, yeah, that would help. This is a void function. Try that again. What else did I mess up? Get ID. Right, I need more of those arrows because I put all dots in here. Arrow, 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 arrow. Okay, that should do it, yeah? There we go. All right. And look what's happening here. So we set the ID for our control unit to be 5. And for C, our pointer to a control unit, it's 5. And for C2, also pointer to a control unit, it's also 5. When we use C2 to set the ID to 50, notice that it changes both of these. And so what we've done here is we've said that anytime that we create a control unit, first of all, the only way to do it is by calling get instance. If I do anything else, I can't actually make a control unit. And also, all these control unit pointers will only ever point to this one instance here. So this is the singleton pattern. Some people consider this to actually be a very bad pattern. I am one of those people. I don't think I have ever used this in a practical scenario, but it is nevertheless something that is present in a lot of code out there. So it is good to know that it exists and how it works, just so you can understand, what are these words static doing? Well, the word static here is making sure that this instance is only ever pointing to one thing, no matter how many control units I make, how many control unit pointers I make, I should say. And also, when we are trying to get a control unit, we can only ever get the one control unit that exists. So I can call this function by saying control unit, get the instance, and that will allow me to get whichever control unit is the one that exists. Okay, so this is our singleton. Let's move on to the next pattern. So pattern number 2 is going to be factory. We're going to make a smart device factory. A smart device factory will create devices, which could be new smart devices, either lights, thermostats, or cameras. So let's make all this stuff happen. So for example 2, we're going to make our smart device factory. We can put this up here. So first of all, we need to make smart devices. That's where everything kind of starts from. So a smart device. I don't think we'll have this do anything super fancy. I think we may even actually have this just be an abstract class. So we need a virtual function, void. How about we just call it operate? It seems fine to me. No parameters, equals 0, because this is an abstract class. Our class light will be a kind of smart device. And when we operate a light, we'll just say lights on. Then we'll do the same thing for our thermostat and our camera. So camera on, thermostat on. Okay, so I got my different kinds of smart devices that do whatever they do, reporting according to how they're supposed to work, and they all are kinds of smart devices. Now what I can do is I can make a smart device factory. So my class is called Smart Device Factory. You can choose to make this a singleton class if you really want. I don't think it's necessary. We're going to try to keep this as simple as possible. Our Smart Device Factory is only going to have really one purpose, which is a method called createDevice. CreateDevice needs to return a pointer to a smart device. And it will take a parameter, which is a string, which is either light, thermostat, or camera. So this will be device type. If device type is light, then it will return a new light. I think that should work. Else, if it's a camera, return a camera. If it's a thermostat, return a thermostat. Else, output invalid device type, return a null pointer. So now what I should be able to do is use the Smart Device Factory to make a bunch of stuff. So we'll comment out our code here. And we'll say, all right, let's make our Smart Device Factory, SDF. And then I can say, how about we say, but we then ask the user, what device would you like? Light, thermostat, camera. String input, read in their input. And then I can say sdf.createDevice given their input. So this will give me a device, and then I can operate it. And the method is operate. So let's try it out. Did I make a mistake along the way? Nope. Okay. Give me a light. Light's on. Give me a camera. Camera on. Give me a thermostat. I spelled thermostat wrong. Invalid device type, and then it crashes. So gotta be careful for this kind of thing. You can always put in a try catch to verify that nobody is trying to call this method when the thing doesn't exist. But I do believe that is our factory. So we're now able to ask the user, what kind of thing do you want, and make that kind of object. So as opposed to, just like having a bunch of if statements here that say, if they put light, make a thermostat, make a light. If they put thermostat, make a thermostat, and so on. We can basically take all of that functionality away and put it into a factory. And here is where it actually does the business of figuring out which object to create. And in any case, what I get back will be a smart device that has a method called operate. Since that method is virtual, it will always run the appropriate version of the operate. If I had chosen up here to say, instead of equals 0, operating device, because it's virtual, it will still say lights on, thermostat on, or camera on, depending on what it is. Okay, so that's our factory. Let's move on to the next one. So this next pattern is a bit of a review, because we've already done subject and observer, but this is a pretty important one, so I think it's worth doing another run of it. Now, what we're going to do is we're going to update our control unit class from before to make it a kind of subject and give it an operate function that calls notify. And we'll make some observer classes. mobile and web dashboard that will print some messages. Let's duplicate here. This is example 3. Let's make our... let's actually put this down below. So we have our smart devices. Let's go over to our control unit. So before I can make my control unit a subject, I need to define what it is to be a subject. So what is a subject? Well, a subject is something that has observers it can attach, which means we now need to say what is an observer. An observer is very simple. An observer just notifies. So it is an abstract class that is going to have void notify, no parameter. I guess, should we have a string parameter? Yeah, we'll have message. So there's our virtual function, notify. It takes a message and then does something with it. Our subject is going to have a vector of observer pointers called observers, and is going to have a or sorry, this one's called update. The subject has the method notify. So void notify, given a string message, for auto observer in observers, observer arrow update, given the message. So give the message that we're notifying with to each of our observers. Also means we need to be able to attach an observer. So here we can have void add observer, given an observer pointer O, and this is just observers dot pushback O, which means I can make this private as it should be. Okay, so now a observer is just something that updates. A subject is something that I generally want to inherit from. It doesn't have to be abstract, but in this case it will be. And what it will always be able to do is add observers to its vector of observers and also notify all observers of messages. So control unit, we can now say, is a kind of subject. And we will also have, I guess I don't really need to do much else here. I guess I need to give it a operate function that calls notify. Sure, why not? So void operate. And this one we will simply call notify operating the control unit. So it calls notify. We'll make some observer classes. So let's make a mobile app, which is a kind of observer. And for its void update function, you got a mobile notification. It says, we'll output the message. And then we'll make our web dashboard. And for here, I can say something else. On the web dashboard message. Okay, so I got two different kinds of observers. I have now my control unit is a kind of subject. So let's get rid of this from before, and we'll bring back our control unit. And for our control unit, we will actually just say C operate. Let's see what happens when we operate our control unit. Oh, actually, nothing should happen. But let's make sure I can compile everything first. Okay, what did I mess up? I forgot to include vector. That was my first problem. I know that just because it says vector doesn't name a type. That's my only problem. That's good. Okay, so nothing should happen when I run this. And the reason is because I am operating my control unit, which says to do a notification, but I don't have any observers. No one is actually looking at my control unit, so I can't see it working. So I need to make a mobile app MA and a web dashboard WD. And then I can say C, what is it, add observer. Now, I'm going to need to get the address of my mobile app and the address of my web dashboard because they take pointers. But now I should see messages pop up. Let's try it. Hey, so now I get mobile notification that says operating the control unit, and on the web dashboard it says operating the control unit because I have added these observers in order. And when I operate, it calls the notify method with the message here, which is operating the control unit, which goes here and for each observer updates them. And there we have it. Now, obviously, I can change how operating works. I can change how to display things with my observers. The point here is that now I can make as many observers as I want, add all of them to my control unit, and anytime I operate my control unit, it automatically tells every observer what is happening, which is the idea of this design pattern. So that wraps it up for this one. We're on to our very last exercise. So for our final exercise, we're going to make a decorator for smart devices. We'll add a energy saving decorator class that prints out saving energy when operated, and a logging decorator class that prints logging data when operated. So let's try this out. Okay. So to make a decorator for smart devices, I'm first going to need to define that smart device exists. Then I will need to have a smart device decorator, and then I will need to have specific kinds of those decorators. So let's start with our smart device decorator. So how does this whole thing work? A good thing might be to actually take a look at the slides to talk about the decorator pattern before I get started. So the idea here is that the decorator class is going to inherit from a base class. It's going to have a reference to an object of that class, and the subclasses of decorator, which are going to be our energy saving and our logging decorator, those are going to override the base class abstract methods, but also call the method from the reference object. So here is an example of what this might look like. So here we have class component. So the translation for what we're working on right now is instead of component, we have smart device. Now, we have our different concrete components, which are our light, thermostat, and camera, and when we operate them, things actually happen. So now here, my decorator is going to inherit from my component. So what that means is that my smart device decorator is going to inherit from smart device. Now, it's still going to be abstract. I still don't want to be able to make smart device decorators. I want to be able to inherit from them to create the actual energy saving and logging functionalities. So let's take a look at what we have here. We're going to have a pointer to an actual object of that kind. So let's mirror this as we're working through. So protected, we're going to have a pointer to a smart device. We can call it device, that sounds fine. Our constructor is going to accept such a pointer and assign it. So, okay, we'll do that. And that constructor should be public. Actually, should we be public? Yeah. So, smart device decorator, given a smart device pointer SD assigned to device. So there's a constructor. And when we operate our decorator, it should call this pointer and run its operation. So basically what that means is that we have a, and I think the name of this should be the same as this. Yes, they all should be called operate here. So that means void operate, because again, I do have to implement this, is going to simply be device arrow operate. So this is my smart device decorator. This is and so the goal here, what I'm trying to really do is be able to make sure that I can create a class such as energy saving and make an energy-saving light, for example. And the only way that this is going to work is if I can have a class that is going to hold on to a pointer of the real thing, the light, and be able to also say saving energy when I am operating the light. Now that I have this class here, I want to have another class, energy saving decorator. And we can see this is kind of on the following slide. So this is where we have the actual decorators that we're going to be creating. On the left here, you can pretend this is the energy saving, this one's the logging. How does it work? Well, it's also going to take a pointer to a smart device. But notice here, it's going to call the parent's constructor. And so what that means is that for my energy saving decorator, which is a kind of smart device decorator, the constructor here is also going to take a smart device, SD, and it's going to call smart device decorator with SD. Now, do I have to write virtual here? I don't think I do, but I'm not actually sure. We'll find it as we go along, I think. Okay, so now it is a kind of smart device decorator, and we also need to have a void operate. And here is where the actual usefulness comes in, which is I can say saving energy before I operate the device. And it'll do the same thing for my logging decorator. What is it called? Yeah, logging decorator. That says logging data. Okay, and now what I should be able to do is make an energy-saving light, and how about a logging thermostat? So way down below here, dump this for now. Okay, let's comment all this out for the moment. I mean, I guess I can leave some of this stuff here, it's fine. Okay, so I want to make a so first let's make a light. My light equals, here if I really want, I think I can, yeah, I can just probably say new light. Okay, so now I have a light, and I want to make a energy saving decorator ESD light equals energy saving decorator, giving it my light. And I can say ESD light operate. Let's try this first, see if it works before I move any further. Clear, compile. What did I mess up? Base operand is a energy saving decorator. All right, it's not a pointer. So I can just say dot operate. Hey, look, I'm saving energy for my lights that are on. I also can repeat this process, where instead of a light, I can say, how about I make a thermostat by thermostat equals new thermostat, logging decorator, LD thermostat is a logging director of my thermostat, and I can operate that as well. And so now, when I run this, I'm saving energy with the lights on, and I'm logging data with the thermostat on. And so essentially what I'm able to do now with these decorators is that I can attach them to any one of the smart devices I want, whether it's camera, thermostat, or light, and add on extra messages that go there. Now you can imagine in reality, if you actually had an energy saving thing, maybe it changes, the consumption of power and the the amount of illumination for something like a light. But the general idea here is that I can still call a method called operate from my ESD light, and it will still run the light, but it will also do other stuff that I can add on to it. And now the computer doesn't actually realize, for instance, like I'm still able to accomplish everything I'm able to do with a smart device. But, and in fact, notably, if you kind of go all the way back up, what is a a decorator, a logging decorator is a smart device decorator, which is a smart device, which means if I have a vector of smart devices, let's say I do this. So let's not operate these. We'll say vector of smart device pointers devices. In fact, how about we actually put such a thing inside of our control unit, because that kind of makes some sense. Here's my devices. And when I say operating a control unit, how about for auto device in devices, I just say device arrow operate. And now I can uncomment a lot of this stuff and see what happens. How about we actually uncomment out as much as we can and then run our control unit and see if it makes everything go. So here's our control unit. Now we do need to be able to add devices here, so I suppose I should add a method, void add device, given a smart device pointer, SD, devices.pushback SD. So now my smart device can add devices to it that it'll be able to operate. I got my energy saving light, my logging thermostat. We'll even ask the user for another one. But instead of operating that other one, we will say, and let's put this up at the top. So we're gonna make our control unit, attach the mobile app and the web dashboard. We'll make some devices, including one that the user chooses, which one they want, just a regular kind. And when they create that device, we'll add it along with our other devices to our control unit. So C add device ESD light, C add device LD thermostat, and C add device the one that we're creating right now. Let's try all this out, see if we can put it all together. Oh, some mistakes. Right, because the energy saving decorator and the logging thermostat I did not make dynamically, which I should. So here I'm just going to add these and I'll say new. There we go. Okay, try that again. Clear and go. Let's give me a camera. And now look what we got. Mobile notification says operating the control unit. On the web dashboard, operating the control unit. And when we operate it, we run our saving energy light, our logging thermostat, and our camera as well. And so we've put all of our design patterns together. We have the singleton pattern as used in our control unit to make sure we only ever have one control unit. In fact, if I go down below and I say make a new one and operate that one, you'll see it actually will do the exact same thing. C2, operate. Camera. See, that actually will run it twice back to back. We are using the factory pattern because now we can allow users to choose whatever kind of device that they want. Maybe if we even want to, I would recommend trying to extend this so that you can add on some decorators to these as well. Perhaps you modify it to make a smart device decorator factory, which will allow you to modify the lights, camera, thermostats to make them energy saving or logging as well. You can do this, try it out. We've also added observer and subject functionality for the observer pattern so that when we run our control unit, we can have our mobile app and web dashboard print out messages to say, hey, we see things are happening. And last but not least, we have the decorators themselves, the ability to make our devices into energy saving or into logging or whatever other functionality you want to add. So this combines kind of all these ideas of everything we've kind of discussed in this course into one little exercise here. We have our smart devices, our decorators, our factories, our observers, and our singleton control unit all in one file. So hopefully this was a helpful exercise. I definitely recommend looking over this code. Although probably looking over the code, I honestly think is not that useful. I think that a better idea would be for you to try to implement all of this. Make this all work from scratch. See if you can follow all the steps that I followed. because that will help you get more comfortable with coding and hopefully will make you a better programmer. So make sure to code. The best way to get good at this stuff is just doing it over and over again. Don't expect that watching a video is going to be enough. You really do need to actually put your fingers to the keyboard and make stuff work if you want to be good at programming. So that wraps it up for this video series. Thank you so much for watching, and I hope that you have a great CS career. Looking forward to seeing how things will go for you. So thanks again. Bye-bye.